Okay, so let's look at another very important distribution, which is normal. Okay, so this was uniform. Let's look at normal. Okay, so let's quickly let's quickly draw the PDF of standard normal. Okay, let's just do that. Okay, so how do we do that? Well, okay, so again, I'll do the line graph. Okay, so I'll draw, let's say from minus 5 to 5 will be sufficient, because probability that a stand normal random variable lies between -3 and 3 is close to 99.7%. So we can just draw something between -5 and 5. Okay, so x is SEQ -5 to 5 with an increment of, let's say, 0.01. Okay, and you can use dnorm, okay, for the PDF. The same thing, just put d in front. Okay, so dnorm for the PDF. So let's say dx is dnorm. Okay, so you can see the default is standard normal, so you don't have to specify mean and the standard deviation, because that's by default standard normal. Of course, if you want to do it for some other normal distribution, you have to specify the mean and the standard deviation. So let's just, because we are using standard normal only, so we don't have to do that. Okay, dx is dnorm x. Okay, and now let's do the ggplot. Okay, so I think it's the same kind of code, so let me just copy from the top. Okay, so can you see this? Just it's the same thing will work. We have created the data, okay, with x dx values, and just let's run this. Okay, can you see this? Okay, this is the plot of standard normal density function. Is that fine? Okay, though it's actually a line plot. I mean, if you really think about it, it's a piecewise linear plot. Okay, so if I don't create, such finer, just tiny steps, because of these tiny steps, it looks like a curve. But if I change this to 1, it will not look like a curve. It will look like a piecewise linear function. Can you see this? Okay, so it looks like a curve because we create this, really, uh, we have these, we take very tiny steps, so that's why it looks like a curve. Okay, so it's actually piecewise linear function, okay, that you are plotting. Is this fine? Have you all understood this? Any questions? No? Okay. Good.
Sure, about the universality of the uniform. So basically, it says the CDF, the random variable of CDF of any random variable is normal distribution.
No, no. So if you take any random variable, plug that random variable in its own CDF. That will have a uniform distribution. No.
No, I think he was talking about central limit theorem because he's talking about.
Oh, okay. So take any random variable. You have a CDF for that random variable.
CDF of any
Feed the CDF of the random variable with its basically own random variable. So basically take then the random variable, just feed it to its own CDF, and the resulting random variable will be a uniform 0, 1 random. Okay, so let's just quickly verify this again. Okay, quickly verify universality of uniform again. Now what we are going to do is we'll generate random numbers from normal distribution. and we'll plug them into the CDF function of normal distribution, and we should get a uniform 0, 1. So we should get a plot like this. So why don't you want to try? Okay, so generate maybe 10,000 observations from normal distribution this time. Okay, and use the CDF. You already know the CDF function. Okay, and then just create a histogram plot of CDF of the normal. Like, so the numbers that you've generated from the normal, just plug them into the CDF of the normal, and then create a histogram plot. You should get something which is uniform. Okay, why don't you do it? Take 5 minutes.
So could you please repeat what you just asked us to do?
Yeah. So what I'm saying is that you need to do this. Okay. So generate 10,000 observations from normal distribution, standard normal distribution. Okay, 10,000 observations from normal 0, 1. Okay, and once you have generated these random values, these are those x values, right? I mean, these are these x values that you have generated, and you also know the CDF function for normal distribution, which you can use pnorm for that. Okay, so take these 10,000 values, plug them into the CDF of normal. Okay, you will get 10,000 values. These resulting 10,000 values, if you plot a histogram for that, that should follow uniform distribution because of the theorem that we just did. So now we are applying the theorem directly. Earlier we were using the inverse. Now we are actually applying it directly. Okay, so just check that. Okay, so basically fxx should be roughly uniform, right? Yes, fxx is uniform distribution. So the data that you have generated should also follow the similar thing, right? I mean, it should also be uniform 0, 1. Yes or no? Okay, so is the question clear?
Yes, sir.
Okay, yeah. Okay, let's just do this quickly. Okay. Okay, so the first thing that we're going to do is we'll generate 10,000 observations from our norm. Okay. 10,000 observations from normal distribution. Okay, the next thing that we're going to do is we'll feed these values to the CDF of normal distribution. Okay, and these should be 10,000 uniform 0, 1 draws. Okay, that should be the case. So p norm x, so u is p norm x. Now let's plot the histogram plot for u. Okay, let's run this. See this?
Yes, sir.
Okay, you generated random data from normal distribution, and then you actually plug those values into the CDF of normal distribution, and then you got 10,000 observations for uniform 0, 1 distribution. Actually, those are actually coming from uniform 0, 1 distribution. Have you understood this? So this is another way of drawing random numbers from uniform 0, 1 distribution. Really think about it. Yes or no? Okay, so if you know how to generate random numbers from normal distribution, you can generate random numbers from uniform 0, 1 distribution like this. Is that okay? Here? Okay, good. So yeah, so we can actually just verify, how to find. So probabilities is something which is a very important question with normal distribution. How to use normal distribution to compute the probabilities associated with different intervals, you can use the pnorm function, okay, to find those probabilities, okay, because denorm function is just going to give you the PDF. So you have to integrate the PDF to get the probabilities, or you can just use a pnorm. Is that okay? So let's use pnorm function. We already know how to do the how to use the pnorm function. Okay, so let's say x is normal 21. Okay, so mean is 20 with 1. Okay, fine. Suppose I want to figure out what is the probability that x is between 19 and 21. Let me just put comment. Okay, what is the probability that x is between, anybody knows the answer? Of course, you have to do the integral, or if you remember 68%, 95%, 99.7% rule, which says that within one standard deviation away, if you want to figure out the probability that x is within one standard deviation away from its mean, where x is normal, then the probability is 0.68 roughly, approximately. So that is what we should get, because this is exactly the same question. What is the probability that x is within one standard deviation away from its mean? So we should get close to 68%. The answer should be close to 68%. Let's just use pnorm. Okay, so pnorm 21 will give you, okay, mean is 20. Okay, standard deviation is 1. Okay, pnorm 21 will give you the probability that a standard normal random probability that the normal random variable takes value less than or equal to 21. Okay, and then subtract from it what? Pnorm 19. Okay, you can just put 19 here, it doesn't matter. The reason is because it's a continuous distribution. Okay, so probability at a point is 0, so it's not a problem. Okay, you don't have to put 18.999 or something like that. Okay, there's no need for that. Okay. So just run this. 0.6826. Okay, so that's the normal 68%. Is that okay? Yeah. Have you understood this?